Sound check. Sound check. And that worked. All right then. Wait for a little while. Let's
just check if you receive the email then. You've never received anything from that email address. So you
Hello. Last time we were here, I was stuck here and couldn't get wasn't sure exactly how to do an equals on the on vectors, or basically ordered containers. And so I figured it out. I went and looked at the Catch2 manual and figured out what I was supposed to do. I actually asked ChatGPT first, and ChatGPT gave me a bunch of garbled answers because it didn't know which version of Catch I was talking about, and it got answers that are relevant to different versions mixed up, and, well, yeah, one of the reasons why you can't trust LLMs. So, there we go. We have a test. And the important thing about this test, there's these matcher things here, and then this require that it takes two arguments, not just a Boolean expression, but it also takes these two matcher things, or this matcher thing is a second argument, and that enables it to have a bunch of overloads and things and do the right thing with the kind of thing that you're trying to do a comparison with. I'm actually not at all sure precisely how this the equals one works, because it actually can figure out which one is the one that you expected and which one isn't. And yeah, I'm kind of impressed that it works at all. But this one is for types that are more sophisticated than just integers or strings. So now we go down to this other one that we were working on down here. And this one is great, like a result evaluate one, like, yeah, that's what we want. But we now want to do this other thing that we were doing up here, which is the thing with creating this, the save result here. I'm gonna copy this down here. It's gotta be a way to have a fixture for this. I mean, I could do this. That would mean I'd have this save result thing for all of them. And that's not necessarily a bad thing. It's not that much initialization to create it. So, maybe I will do that. Maybe I will do that. And then I can just eliminate it from here. Because it's just you shouldn't have to repeat yourself all the time. So we'll do that. And then this part down here, there's just no avoiding doing some amount of repetition. That's how it's all about testing, right? So let's run it all again and see, do our tests still pass after making this change? Indeed, the tests still pass. Okay, that's great. Now we can look at what he did here, right? So here's what we'll do, and no, that's not what I wanted. I wanted that. And this should be 1. And here we should stop calling it result. I should actually change it like calling it AST top everywhere, but rename this. There. Don't want to call it result because that starts getting confusing when you have save result and current result and all of that other stuff. And so best just to call it AST top because that's what it is. As I said, probably should call it that everywhere, but I'll change it piecemeal as the tests require, as the tests need it in order to remain reasonably clear. So this is no longer correct, and this is going to be a lot more complicated. So I'm going to do this with it. Now, the first one, expressions with Boolean operators. So all of this, 5 minus 1 is 4, times 5 is 20, and 1. So that should be 1. Then the next one, 5 times 6 minus 6. So, oh, actually, I'm sorry. Should not be 5 minus 1 times 5. 1 times 5 is 5. So this actually should be, I'm going to leave it at 1 just to test. This one, 5 times 6 minus 6. 30 minus 6 and 1. So 5 times 6 minus 6 and 1. 5 times 6 minus 6 and 1 will be 29. So if it does that binding, that's what's going to happen. If it does this binding and then that, it's going to be 5 times 0 and 1, and it's going to be 0. But if it does the one it's supposed to, 5 times 6 is 30, minus 6 is 24, and 1 is going to be 1 again. Or not 1 again. The first one was supposed to be 0. 0 and 1, 0. 1 and 0, also 0. 0 and 0, also 0. 0 or 1 and 5 is going to be 1. 1 and 5 or 0 is also going to be 1. Sadly, this doesn't turn out correctly if it does it in the wrong order. Like if this one does 1 and 5, still, again, it turns out correctly even if it does it in the wrong order. I need to figure out how to fix this, but I think here 0 and 6 and 0. So 0 or 6 is going to be 1. 6 and 0 is going to be 0. So this is going to be 0. Then this next one, 0 and 5 or 1 and 0. So if it does this one first, then it's going to be 0 and 1, which is 0 and 0, which is going to be 0. But if it does this, 0 and 5, or 1 and 6, then it's going to be 1. 5 or 0 is going to be 1, and 0 is going to be 0. But if 0 and 0, then it'll be 1. So this one is another one that will crop up with the wrong answer if it does things in the wrong order. And this should be 1. Right? And so now let's see here. Let's put in comments for each one. Oh. And this one should be 0, 0U. All the assignment statements should be 0U. Okay. No, this is there. So then this one will be this one. 1 and 5 are 0. And 0. Then this one is I think I missed one someplace, so I need to double check all of these. Actually, no, maybe I didn't miss one. Okay, so is this thread? Yes, yes, yes. This should be 0, but this is a test case to make sure that the test works. This should be 1. This should also be 0, 0, 0. Also should be 1. Also should be 1. Should be 0. Should be 1, because 0 and 5 is 0, or 1 is 1. Oh. No, it should also be 0. Because 0 and 5 is going to be 0, or 1 is going to be a 1, and then and 0 will be 0. Now 5 or 0 is going to be 5, and 0 is going to be 0. 1 or 6 is going to be 1. Okay, so let's try. Oh, I forgot that. Forgot that part. Zero, 0, 0. Okay, so this one should have been 0, and I made it 1. So now let's try running it. Yep, worked. All right then. This test is complete. Let's see, does this fit into 68 characters? It does. And it needs more explanation. So there, simple expression needed to be slightly complexified to make it useful for storing the results of evaluating a whole bunch of statements, and we needed this in order to make succinct tests, and it needed to be moved to the header again to make it available to tests. So that's a longer explanation for what we did. I don't know that I could make this succinct one, the first line, more compact. Partly we're doing two things in the same commit, sadly. And that's part of the reason why it's this complicated. Should avoid doing that. Just like that. And run our tests again. Woohoo, they all run. Okay. So what's next after this? So we have some Boolean operators. I was thinking maybe having a simple if statement. Now I could have had an ersatz if statement sort of by doing ampersand, but if statements don't require side effects, but they kind of have side effects. I mean, they're easier to test with side effects. I don't know. I could do the if statement even without, and test it even without expressions that had side effects. By using ampersand, by making ampersand short circuit, I could have avoided having the one side or the other run. But that would require the if itself to be an expression that had a result. Otherwise, there is no way I was going to be able to pull. And I don't want to make if that way. I don't want to rewrite Lisp. And so I'm not going to have the if statement have a result. The if statement is going to, So I think that's the next thing that I'm going to implement is an if statement. So what's that going to look like in our grammar? So parser.hpp has a description of the grammar. Now I could do this so that, but then you couldn't say if equals, or I could say that if you did do if equals, but then, it would make it too ambiguous. If is going to be a keyword. You're not going to be allowed to use it as an identifier. And I'll signify that something is a keyword by making it caps, even though the keyword itself is not caps. So we're going to have to do something here because statement is about to become more complicated. So what we'll have to do here is we'll have to do and I'm overloading equals, but there. And then I can add another thing. I can say, can also have if. So I'll make it all caps, but then put the actual text in friends. That's what I will do. Do I like that? This is a pseudo BNF anyway. So Oh my. There, that's what I will do. And then here we have an actual parens here. And then here we're going to have and the sequence part is going to be optional. We may not have a sequence here, and so here we will have and then we're going to have which will also be a keyword, although the case here for making it a keyword is no, it should still be a keyword. Okay, this is C-style if statements. And then this part should be optional. Yes. So this part is optional. If, and then you have an expression in here, block or expression, else block or expression, like this. That is what an if statement looks like. I had to introduce the idea of a block so we could have a sequence of statements inside the block. And I had to introduce split up a statement so that it could be this, which also means I have to do Now what we're going to do here is we're going to order these in the order that we actually do the testing. Like that. So if or assignment or expression. So statement might be one of several different things. This is interesting because I'm demanding that all statements end with a semicolon. But if statements don't need to end with a semicolon. Assignments do. If statements don't need to end with a semicolon because it's just totally unambiguous here, except here, yeah, this is a very interesting thing. Here is the difference here. We're going to have and I'm going to have to put the quote, semicolon in quotes in order for it to be consistent. Now we need statement followed by a sequence. So a statement followed by some other number of statements. And then this will have to be expression statement. And then this is going to have to be expression statement as well. So expression statements have to end in a semicolon. Assignment statements also have to. We're going to do it this way. This is, yep, like that. Assignment equals that semicolon. Expression statement equals that semicolon. Yes. And we'll put these also in the order that they appear there. And then here we can say block or expression statement. And then here we can say block or expression statement. No. All right. So this is going to require some major refactoring of the grammar in order to make it work. We're going to take that refactoring in stages. Because the first thing we need to do, now that we know what we want to do, is we have to change. So this is the ultimate version of the grammar, right? Like this. But we don't want to get all the way there right away, because we basically want to make the minimal change that we need to make. And so we don't need block. We don't need if statement. We need to change the definition of assignment. We need to change to have expression statement. And there we go. So we need to make, this is the grammar, the first version of the grammar that we want. And then this is the ultimate version. Okay. But I'm above grammar first. So, why am I going to do this? This is the current target grammar for the next sequence of changes, but I'm going to implement the changes for the above grammar first. And the reason why we're going to do this is this grammar is essentially equivalent to the grammar we currently have. So everything, there will be no new parsing. Like there will be no new thing that gets parsed. Everything that gets parsed will be the exact same thing as what was parsed before. And honestly, I should put these in double quotes just to indicate that they are tokens. And I should do that in the target grammar too. Just to distinguish things that are tokens from things that are not. And here we'll leave numeric literal and identifier and stuff as terminal tokens, even though previously we've capitalized, like down here we're capitalizing some tokens, like the if token and the else token. I think, I don't know. Maybe I should capitalize the identifier token. And the numeric literal token. Like that. And here, okay, if we put quotes around the equals, we're no longer overloading it because we're indicating that we have equals as a token. And so this is all good. And then down here for block, yep, which means we need to, once we get to this one, we'll have to implement 3 new tokens. Or 4 new tokens. We'll have to implement the open brace, close brace, the if, and the else tokens in order to make all of this work. But for here, we don't have to introduce any new tokens. And I am going to go down here and fix expression to be the same. Fix bool term to be the same. Fix this same. Make this be the same. And there. So token terminals will just be capitalizing or putting in quotes. That is the rule that we will use to make this a little more regular. And I don't really think I need to do this in order to make this work out right. We'll just do this. And we'll know what that means. It's all caps, that means it's a token. Yep, now let's see. I'm just scanning through to make sure that I remember to fix everything. Quotes, 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 quotes. So quotes for all the stuff that needs quotes. Yep, I believe that this is good. All right. Yep, that's good. That is not good. It's too long. More like an actual BNF grammar and less like a there. People can go look up loosey goosey if they want to. I'm going to ask Claude just to see what it says. What does it think we should do? So it's suggesting all kinds of things that I might want to do. And I'm going to stop it. Claude was not useful here because there's a bunch of things that need changing, and Claude wasn't. Yeah. Wasn't helpful. Because I have expression statement, and yeah. So we will just do it ourselves. Parser.hpp. So we have this sparse statement list, which probably should be renamed to parse sequence. So we will rename this. So it gets renamed parse sequence, and I trust that this rename, like if we do an htdiff now, right? There are a bunch of places where parse sequence is mentioned, and so they all got changed to mention parse sequence instead. So that's good. I might actually, what I might want to do here is just say there. Now what I can do down here in the tests is I can say, whenever I can just search for and just select them all. This is not what I wanted to do. So I'm still very confused about how to make this whole search and replace like this. We want Alt-J repeatedly here. Right? Like that. Like that. We want to make it parse top instead. Too many backspaces. Now it's like, oh, parse top is a variable, which yes it is, but this should still work. Yes. And the test should still all run. I really need to it's now a name alias for the main production. This is a mechanical change that touches a lot of lines, and so that's one of the reasons why I wanted to do it as its own commit. Tiny little commits. Okay. So now we want annoying JetBrains and your inability to handle focus. Now we need a couple more productions that we didn't have before. Before, we did not have I am going to change expression statement and eliminate block because I don't think block is useful. In fact, I'm just going to modify expression statement later and not have block at all. I'm going to change expression statement so that an expression statement can either be an expression with a semicolon or a block. And then like that. And yes, that is what we are going to do here. So we're going to pull parts of parse statement out. In fact, parse sequence is currently contains parse statement because this, yeah. So parse sequence currently contains parse statement, basically. And yeah. And we're still going to continue that. It's going to still continue with statement, but we're going to go about this in a little bit of a different way. assignment, comma, what's it says? Right? Yes. Yes. Yep. Right? And then the semicolon parsing isn't here. Yes. Sadly, this means that there's going to be two places where a semicolon is being checked for. But a lot of this code here and then here we're going to say that. I'm going to paste a lot of this in here. This is still worthy of a diagnostic. We need a better way to do diagnostics than what we're currently doing, but this is a good diagnostic still. And this is the else. And down here, that's where we do the... So if we get all the way down here without a successful result, otherwise... this. No, we don't need this anymore. Why do we want the... It's not redundant. This is a assignment statement, right? No. Like that. Yeah. Yep. Just like that. Except that's not quite right. Like that. Okay, I am looking for a specific kind of thing. Oh, I see, yes. Yep, just like that. All right. Alright, so we've parsed our this is a parse of the assignment, this is a parse of the expression. Let's do a build here. Okay. Oh, there should be no semicolon there. Now let's do a build. Now it worked, and this else is not redundant. So both of these are errors. Like if we see identifier and then equal, and then everything else doesn't match up. There's not much else that, in fact, there's nothing else in our current grammar that expression equal could mean. And so this is definitely like an actual parse error. And this is kind of special casing. Now, why it thinks this else is redundant? Oh, it thinks the else is redundant because there's a return statement here. Yes, that is true. No, I don't want to fix it. But there we go. Okay. And then this is there's no parse expression statement. And so I still need to write that. And this parse assignment is too long, and so we're going to do this standard thing here that we've been doing all along. This, that, like that. Same thing. Definitely the same thing here. Parse expression statement is a very long name. Like that. Okay. There is no return statement. This is true. So if we actually got an expression, and then we look to find out like this. Then otherwise, if this isn't true, basically if none of this is true, then we just like that. There we go. And this is all correct. So I'm going to ask Claude if it notices anything that's significantly wrong. talking to someone else, thinking of going out later after I get done streaming. It is taking a long time. So we'll see if it gets stuck in the same place. If it does, we're going to give up on getting Claude here to evaluate whether we did the right thing. I always like telling Claude what it did wrong, because maybe it'll get back to the people who implemented it. To restructure the productions. So, telling Claude what it did wrong, just to see how it responds. Exactly. So Claude is a little like overly effusive in telling you that you're right when you're right. But there, Claude just told me that I did the right thing here. And let's look at the diff here. Use structure. And again, I really need to make a pre-commit hook that does this for me. Exactly 68 characters. And that is exactly what that change is about. So, now that we've made that change, now let's go about adding if statements. So this grammar is now obsolete. One thing I'm going to do is, when I thought about this is the wrong way to go about doing this. What I really should do for this is I should actually have expression statement mean either or it should mean it should mean one of those two things. And then I can, instead of saying block or expression statement here, I can just say expression statement. And expression statement. That does have the side effect of allowing me to randomly insert blocks, curly brace separated, curly brace things in the middle of sequences. But that's okay. That's exactly how seed works, and so I'm going to do things this way. Yes. So now this is the updated production that we will be implementing for the if statement. And that means we don't have to have a separate block. We can just reuse expression statement and modify it slightly. Yeah. Oh well. And the simplifies the if statement a whole lot. And expression statement gets to be reused in a whole lot of places. There are a whole lot of places where we might want to block, and saves us from having to do expression statement or block everywhere. And yeah, this works. It also means that sequence can just be a single expression statement, which that's allowed. And so I can actually make my sequences start with a curly brace. So first of all, let's go about what needs to be done to implement this. First, we need to add 4 new tokens. But 2 of the tokens are related to each other, and so really only there. So we have brace, and then we have I guess we can call it a bracket instead. Curly bracket. We'll call it curly bracket. So we can add square bracket later. And then we have and here we're going to have, and we currently do not have any of these others, so we're just not going to put them in like that. And then here we're going to add 2 more. There. And we'll have the symbol ones here. And then we'll have keyword down here. There. Now, if we want keywords, first of all, keywords are going to be like the first thing that we try and match before identifier. So, like that. There we go. Now we've added a keyword to our regular expression here for our tokens. Now we have to go down here. No, that's not the one we want. And oh, I forgot that we add curly bracket as a thing too. There, curly bracket. Yep, that's exactly right. And this should be break. And this should be break. And then default. Like that. And this is actually an assert failure. This is like a runtime error because the way the regular expression is written, there's absolutely no way anything but these two should be possible for it to show up. Yep. maybe there's a better way to match keywords later. I don't know. But this is the way we're doing it now. But if our list of keywords gets to be particularly long, going through this whole list to try and figure out which keyword it is going to be a huge pain. There's a problem here. There needs to be like a word break at the end of this, which means basically yeah. This is tricky because I would like to parse out if and else, but one of the problems is it has to be trailed by something. And I'm looking for want a negative look ahead. And I don't know whether that's actually implemented by CTRE. So that's what we're going to do. Is this is going to be for identifier. This is going to be negative look ahead for okay, so negative look ahead would be and here we want question mark colon. And here we want question mark colon. And then we're going to put our like that. So the negative look ahead will not be part of the keyword this match here. Negative look aheads, if I'm not mistaken, and yes, a fixed length, so it's exactly one character. So what is negative look ahead? Negative look ahead says look ahead one character. Like it's not part of the pattern or anything, but just look ahead one character and make sure that that character doesn't match. So this is saying, yeah, we don't want a word constituent character at the end of our keyword. To try and make sure that these keywords, because one thing that could match is like this appears before identifier, right? And it should. These are more important than identifiers. They should be matched in preference to identifier, because identifier would match all of these, right? And so, but the problem is we could have a completely valid identifier that was like if else, all one word, right? Or else if, all one word. Those are perfectly valid identifiers. They're a little bit confusing, but they're perfectly valid. So we want to say, okay, well, you can have if, or you can have else, but they must then be followed by something that's not part of a word, so they can't be confused with a longer identifier. And I hope that this will work. And we didn't need that closed parent there. So keyword. Here, if we get a lot of keywords, this gets to be pretty inefficient because we have to test, is it that keyword? Is that keyword? Is that keyword? And so we need a more efficient way to test about keywords. But this works for now. This is all correct. Let's see if it compiles. Because regular expression contains syntax error. At position 249. Oh my. Well, that's kind of annoying. I wish I knew what 249 was. But this is so annoying. What we're going to do is we're going to copy this, and we're going to pull up a okay. Oh, it doesn't like the bracket. Well, that's very interesting. Is bracket like a special character in PCRE? It is. Oh, that's so dumb of me. Yes, it is a special character. So this needs to have a this in front of it, and this needs to have a that in front of it. And now it should compile. It wasn't the negative look ahead assertion, which is the thing I was like all worried about. No, I just made a really stupid mistake involving brackets. So I'm really glad I got it into Python so I could look and find out where character 249 actually was. Sadly, C++ can't really give us better error messages about this kind of thing at this point in time. Maybe in the future, CTRE can use reflection or something and get better error messages out. But, yeah. And we got a spammer in the chat. So... And we are going to ban this person because they I do not welcome spammers in my chat. So, there we go. Parse result. Da 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 da. Okay. Now I should add these to tokenizer test, right? This time I will ask Claude. It's all in the header file, isn't it? I don't like that this is all. Tokenized input should not be in this header. Oh, except it has to be. Ah, how annoying. And it's smart enough to check them on this. Oh, good. So these look basically correct. I'm betting I'm going to have to edit them, but they look basically correct. And I'm glad that it added the test to make sure that okay, so this I might have to edit this into submission, so let me check on this first. So token 0 is yep. Tokens 1 should be X, so token 0 should be curly bracket open. X equal 42, and it's missing. No, it's not. It's not missing the semicolon. There is no semicolon. Oh, no, it is missing the semicolon because there's supposed to be one after 42. So this missed this, and should have added in. Yeah. Okay. This is a persistent problem that Cloud has. It seems to be every time it's gone through and done these tests, it's always missed the semicolon. If paren identifier close paren y equals 1 semicolon, I got the semicolon there, else y equals 0, and then it's missed the trailing semicolon. And also too, tokens.size should be 13. And here, tokens.size should be 6. Just to make sure, 1, 2, 3, 4, 5, 6. Yep. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes, should be 13. Okay. If x equals 1, I mean, sure, we can just skip this, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Got the number of tokens right this time, even though, and it's not trying to check the semicolon, but that's okay. So basically checking to make sure that these don't get turned into keywords. That my negative look-ahead assertion works correctly. String with nested curly brackets. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, you're missing the trailing semicolon again, silly thing. Or, yeah. So, open x equals 1, close, semicolon. So it got that right. But it's missing the second close. It made a mistake and then looked back up and saw that it made a mistake and yeah. Oh, how dumb. Complete if-else statement. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Again, it's probably missing a semicolon in there someplace. All tokens, including keywords and brackets. So, got an if. Got an open curly bracket. Nope, got an open paren. Oh, no. Oh, we're going to skip the condition tokens. Okay. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. No. You got this wrong. 0, 1, 2, 3, 4, 5, 6. This should be 6. It can't count. 7, 8, 9, 10, 11. This should be 11. Okay. Then 12 should be else. So we skip the tokens, we skip the conditions, we skip the tokens for the assignment because we've tested those before. 12 should be else. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. And then open should be 13. 14, 15, 16, 13, 14, 15, 16, 17. And this should be 18. Oh, yeah. Okay. Oh, it didn't like this one. Tokens 3. 0, 1, 2, 3. Tokens 4. Oh. 5, 6, 7, 8. I didn't check these. 4, 5, 6, 7, 8. Build. Unexpected token greater than? Well, yes. Yes, indeed. This is an unexpected token. Maybe we can fix this at some point in time. Yep, there we go. Tempted to say with Claude's help here. Hello there, BBWW. And I'm going to skip the with Claude's help. With Claude's inexpert help. Yes. Although one thing it did do with its test that I'm very pleased by is that it tested out to make sure that identifiers that looked like they might be keywords were not parsed as keywords. That was a clever test that I'm pleased that it figured out it should put in there. So, oh well. All right. Now on to adding the productions, which I am going to do all by myself. Though once we add these, we also have to add them to the, like, make all the visitors support them and all kinds of other stuff. I think I am done for the evening. Enough people have joined and left my stream that I feel done. So we'll go about actually adding the if statement to the parser tomorrow on Thursday. That is what we will do. So, good night all.